Hi, Assalamualaikum and a very good day to all. So for this session, I will share you a topic which is frequently taught in any programming languages, which is array. And I'm going to focus on arrays in Visual Basic. For this module goals, I have several important goals for you. The first one is the definition of an array. The second one, the importance of arrays. And the last one, what problems does array solve? First, we'll see how we can declare and initialize an array. So this is a general syntax to declare an array. We have the dim keyword, which is used to declare any kind of variable, followed by your array name. This can be anything, but please make it meaningful. And then we have the size, where you can put a size such as 4 or any number, or if you leave it blank, you will make a dynamic array. And the last one is the data type for that array. Okay. Example here, name numbers 4 as integer. This one will create an array of 5 integers, starting from the elements on 0, 1, 2, 3, and 4. So there you will have 5 elements. Here we have a dynamic size array, where it is in a string data type. Dim names as string, so you can create many kind of element in string format. And the last one, a complex one, which is a 2D array. The matrix 2 as double. Here we have more than one parameter, so this one is a 2D array, where it has an element of 3 times 3. So to initialize an array is a process of assigning an initial value to a variable or array. It allows you to be used in calculations or to store data. For arrays, initialization typically involves assigning specific values to each element of the array. Example here, I have numbers 0 equals to 10. So the first element will be a value of 10. Numbers 1 equals to 20. The second value of that array is 20. Numbers in bracket 2 equals to 30. So the third element in this array is 30. Usually we will play along with single dimensional array. It's a linear data structure that holds elements of the same data type, like a list or a series of boxes where each box contains a value. So this is an example of a single dimension array. Here we have an array of string. It's dynamic, and these are the values assigned to this array. We have Alice, Bob, Claude, Dave, Eve. 1, 2, 3, 4, 5 elements. And here is how you can display the students' names in this array using a for loop. To access and display a specific element, you can use the number in this bracket, and you can print that element, that specific element, in your application or in your console. We have multi-dimensional array as opposed to linear array, where it is in 2D or 3D. And I use in programming for several reasons, such as structures, the data storage, usually used in a spreadsheet, chessboard, or anything that can be conceptualized in a grid. So this is an example how you can initialize a 2D array. So Alice and 85. So these are two parameters in an element. So this will make it a multi-dimension array. Okay? Bob 92, Charlie with the mark of 78, David with the score of 96, Eve 89. So they are all multi-dimension array. And in this code, I use a for loop to display them. So next we'll see how you can create an array, a demo on how to create an array.
The name to arrays, and we'll go ahead and click OK. Now we will make our form a little bit bigger, and we'll open the toolbox, and we will add a button and a list box. So we'll stretch out the list box a bit. We'll close out of the toolbox, and then we'll make the button a little bit bigger. So we will set the name of the list box to list arrays. So we will just type list arrays, and we'll set the name of the button to button add array. Now we'll set the text value to add array elements. So we'll just go ahead and double click on add array elements to open up the click handler for that. So now what we need to do is come down here and create a sub that will clear the list. So private sub clear list. Now inside of this we'll type list arrays.items.clear. So this will clear all the items in the array, and we're going to be using clear list a lot, and it's easier to type clear list than it is to type all this out right here. So whenever the user clicks button add array, we want to go ahead and clear the list just in case there's anything else in there. And now what we need to do is declare our array. So to do this, we'll type dim, and then we're going to specify a name for our array. So string classes, and then we're going to have two parentheses. And inside these parentheses, we're going to tell the compiler how long we want our array to be. So if we type 5, it's going to be 6 elements long, because when you're counting, it starts at 0. So it'll go 0, 1, 2, 3, 4, 5, which is 6 items. Now we have to specify what data type it's going to be. So we'll just type as string. So each one of the items in there is going to be a string. So now we'll type string classes, and now we need to reference an index of this array. So the item at the index of 0, we're going to set that equal to web design. And we'll go through and do this for each one of the items in the array. Now you can name them whatever you want. I'm just going to do classes here. So we'll type Spanish, and we'll just keep adding more. Okay, so now that we've set a value for each one of the items in our array, starting at 0 going through 5, we're going to go ahead and use a for loop to add all those items to our list. So we're going to go ahead and start off by typing for num1, or let's just do num, as integer. Now you do not have to use as integer because integer is the default for the for loop, but I'm just going to go ahead and do it anyway. So for num1 as integer, we're going to set it equal to 0 because the starting point is going to be 0, and then we're going to do 2. So let's say that we don't know the length of this array. So what we can do to get around not knowing the length, we can just do string classes dot length, and this is going to get the length of it. Now we have one problem here. it goes from 0, and then the length of string classes is actually going to be 6 because there's 6 items in here. So to fix that, we can just do string classes dot length minus 1, which will go from 0 to 5. And so now what we need to do is type list arrays dot items dot add, and we'll do string classes, and now for the index we're going to use num. So the first time this loop is run, num is going to be equal to 0, so it's going to access string classes and then at the index of 0, which is web design, and then the next time it goes through it's going to be 1, which is Spanish, and it's going to go through everything until it gets to calculus, and then it's going to stop. So if we go ahead and run this program, you can see here's our form and here's our list, and now if we click add array elements, you can see that it adds web design, Spanish, chemistry, English, history, and calculus. Now if we were to take out one of these lines right here and run it, we would get an error because you cannot reference a null value. So if you're going to go ahead and practice and make some arrays, make sure you populate the whole array before you try to print it out in a list box, or else you're going to get an error. So go ahead, practice, make a couple arrays. They don't have to be strings. They can be doubles, ints, floats, long, whatever you like. Just make sure you know how to make arrays, you know how to set the values to it, and you know how to access different parts of that array. And once you've got that down and you know you're not going to forget it, go ahead and move on to the next tutorial.
If you're going to write code to create and manipulate a two-dimensional array variable, it's essential that you can visualize the data you're working with. Very often, a two-dimensional array variable is used to store groups of related data items, like the data you can see here. A two-dimensional array can therefore be thought of as a table. These are the data we're going to use in this video. Each row of the table contains the details of a different famous person. The first column contains their first names. The second contains their last names. The third column is gender. Then we have nationalities. And finally, their occupations, what it is each person is famous for. Notice that each column has an index number. Counting starts from 0, so the fifth column is column number 4. Each row also has an index number, and these are also numbered from 0. It's useful to think of this table as having a horizontal dimension, which we'll refer to as the x dimension, and a vertical dimension, which we'll refer to as y, just like the x and y axes of a line chart. When you're coding up a two-dimensional array for a different set of data, I strongly recommend that you keep a sketch of it handy, like I'm going to do now. I can declare my two-dimensional array variable like this. I'm using a naming convention here. A because it's an array variable, ST because it's an array of strings, and people because that's what the data is. In brackets, I've specified the x dimension first, followed by a comma, and then the y dimension. And I've used the as clause to specify that this is an array of strings. Now I'm keeping my sketch of the data handy while I populate this array. It's important to get this right. Otherwise, you might get some very peculiar behavior when you run your program. I want to put Barack in the first column and the first row. I want Obama in the second column and the first row. The third column, first row, contains male. And column number 3, row number 0, contains American. It takes a little bit of getting used to counting from 0. And the final piece of data for this person is president. Now it's tempting to start copying and pasting, but I want to make sure I get this absolutely right. So I'm going to continue entering the values individually, just for now, working from my sketch. Let's get the New Zealand Prime Minister in next. As with the previous famous person, I've specified the column number first, followed by the row number. I've specified X, followed by Y. Notice that the value of X is different for each data item, but the value of Y is always the same, because Y is the row number. Let's do one more, very carefully, and then I'll speed things up with a bit of copying and pasting. And I've just realised that I've made a mistake. It's very easy to do. That's more like it. Now you could initialise each individual element of this array in any order you like, the important thing being that it's fully initialised. But taking a systematic approach like this will help to ensure, if not guarantee, you won't make any silly mistakes. A systematic approach will also help to ensure that all of the data gets in there. But I can see a pattern emerging now, so I'm going to start copying and pasting to speed things up a little bit. Now one last look at my sketch just to make sure I've got everything there that should be there, and straight away I can see I need to change these 2's to 5's. And there it is, the code I need to declare and populate my two-dimensional array. So that's how we get data in. How do we get data out? It's actually very simple if you've ever played a game like Battleships. With this message box statement, I'm going to output whatever is in column 4, row 3. In this case, the word scientist. What if I want to output, let's say, New Zealand? That's in column 3, row 1. Or perhaps the word Swiss. That's row 3, column 3. It's just a matter of supplying the appropriate coordinates. I can also supply these coordinates using variables. Now I could call these variables anything I like, but it makes perfect sense to call them X and Y. Can you see which data item will be output by this message box? Let's see. Now, just like a one-dimensional array, the real power of a two-dimensional array is realised when you combine it with looping constructs. Let's suppose I want to output all of the information about Barack Obama. Notice that with Barack Obama, it's the X dimension which is changing from 0 to 4, but the Y dimension remains at 0. I can do this. In fact, I don't even need the variable Y. Suppose instead I want to output the details of Mahatma Gandhi. Again, it's the X value which varies, but the y value stays the same. In this case, y remains at 4. You should make sure that you're comfortable with this idea before you continue. Let's try Ada Lovelace. Ada Lovelace is in row number 2, so the value of y has to remain the same inside this loop. It has to be 2. Alternatively, I might decide that I want to display all of the values in a particular column. For example, I might want to display all of the last names. If we examine the data, we can see that every last name has the same value of x. Obama is 10, Ardern is 11, Lovelace 12, Einstein 13, Gandhi is 14, and Van Gogh is 15. It's the value of y which is changing this time. So I could write my loop like this. But notice that y varies from 0 to 5. So this time it's the value of x which is remaining the same inside the loop, but y is the value that changes. Perhaps I want to display all of the nationalities. Looking at the code, I can see that all of the nationalities have an x value of 3. Again, you should make sure that you're comfortable with doing this before you proceed. In the next video, I'll show you how we can get all of the data out using nested loops.
See about array indexing. So array indexing is how arrays are aligned or assigned in their element. In this slide, you can see that we have 4 elements. We have 10, 20, 30, and 40. And the way these elements are assigned is starting from 0, 1, 2, and 3. Indices start at 0, and there are whole numbers, which is integers. There are no decimals in indices. And the last one is less than the array size. Okay, as we can see here, we have apple, banana, cherry, date, and fig. These are fruits. They're in strings data type. There are 5 of them, and the way we call them is through the number 0 until 4. Because we have 5 here, so 5 we minus 1, so the last one will be 4. In this example, we want to reassign our array value. This is 20 at the moment. This is 30. Name index as integer equals to 2. And the value of integer, the value of this, we assign it with the value of this one. So 0, 1, 2. Now the value will have this as its value. So next we are going to see a demo of array and index. Array, length, and bounds. So in the real world, understanding and caring about the length of an array is important for several reasons, especially when it comes to software development and data manipulation. Here are some real world scenarios where caring about the length of an array is crucial. And data validation. When working with user input or data from external sources, Knowing the length of an array is essential for validating data. It allows you to check if the data matches the expected size and structure. Array operations. Array operations such as iterating through elements, sorting, filtering, and searching often depend on the length of the array. It ensures that you don't access or manipulate elements that are outside the valid index range. Memory allocations. In low-level programming or when dealing with memory management, the length of an array is critical for allocating the right amount of memory. Over-allocating can lead to wasted memory, while under-allocating can result in memory error. If you play games in a low-spec PC, if the game is intense, the game is taxing your memory so much, your computer will break down. Boundary checking in scenarios when you need to ensure that your code doesn't go beyond the boundaries of an array. The length of an array is crucial for boundary checking. Database queries when interacting with databases or storage system. Knowing the length of an array can help construct queries or data structure with the correct size, ensuring that data is correctly mapped and processed. So here is an example how you can get the right length of an array. Very simple, you use the dot length function. Now using this, you can check the length of your array. So understanding the upper and the lower bounds of your array is important. It gives you some base to assign values. So you know when to stop giving values to your array. So common array operation, number one is populating array. A populating array involves assigning values to the element of the array. You can do this during array declaration or after it is declared. Here you can populate an array. 10, 20, 30, 40, and 50. You declare it. When you give it a value when you declare the array. You can also declare it. You can also give it a values after you declare them. In this example, first you declare them as a 5 element, and you put 4 there. So it's going to be 0 to 4. You can have 5 elements inside your array. You can also use for loops to populate your array. In this example, we will loop the I value, where the I value comes from the first line, and will go up till 9, 0 to 9. And the even numbers will have these values. You can also get your array from your users, where you can use either the dot read line or you can use other method. You can modify array after you have given them their values. You can sort the arrays using the dot sort. You can also search an array where you use a for loop and you use the if switching statement, so that if you found that one, you can exit. You can also filter elements in an array. And that's it. Okay, so creating a complete WinForms PMI calculator is an enhanced exercise from what we have done before. And I urge you to try also the second exercise.
I'm going to show you how to perform a linear search. In other words, how to search through a linear list. In my VB.NET application, I have a form with a text box and a button. I'm keeping it very simple. My text box I have called txtfind, That's where the user will type in what they're looking for. And here I have a button which I've called BTN Linear Search. So let's take a look at the code behind the button. I'll tuck these windows out of the way. And here you can see the first thing I'm doing is declaring the array. I'm calling the array stnames. And I'm giving it the dimension 9. Now that's going to give me an array of 10 elements numbered from 0. By default, arrays in VB.NET are 0 based. In other words, counting starts from 0. And then here you can see I'm assigning a value to each element of that array. I'm hard coding it, which is suitable for the purposes of this demonstration, but that data might be captured in a different way in a real system. And here's the code where I'm performing the linear search. The first thing I've done is declare a variable called stfind, into which I'm putting whatever the user typed into that text box. I've got a Boolean variable called bfound, which I'll set to true if we find what we're looking for. And here's my for loop. I'm counting from 0 to 9. So this is going to iterate through every item in that array. As I visit an item, I ask the question, is the current item equal to stfind? First time through the loop, this is going to be a 0. So I'm asking if the first element of the array, in this case stan, is equal to stfind. If it isn't, we carry on round the loop. I count is incremented, and then I examine the next item. And this continues, examining each item in the array. If a particular item does indeed equal stfind, then we set our Boolean variable to true, and we can stop searching. There's no need to look at the rest of the items, so we exit the for loop. Once we're out of the loop, we can then just test bfound. If bfound is true, we can report that we found what we're looking for. Otherwise, we can say it wasn't found. That's a simple linear search. Let's see it in action. So first of all, I'm going to look for Kevin. Kevin not found. And now I'm going to look for Bart. And Bart is in there. Here's an enhanced version of my linear search program. Let's see it in action first of all. I'm going to initialize the array. I can see here the array is populated. And if I search for an item that is in the array, let's say Maggie, it will tell me so. If I search for an item that isn't in the array, I'm invited to add it to the list. If I say yes, that's been added to the list. So next time I search, I will find Kevin. So how's this done? The first change I've made is to declare the array at the form level. I've done this because I want its data to persist while the form is running, so that any new items I add are there next time I do a search. I've also declared it as a dynamic array. I want to be able to add more data to this array when I need to. I've included a button called Initialize Array. You saw that in action a moment ago. And what that will do is give the array a dimension and put the initial data in there. So there's my set of names that I had originally, and a little message to say that that's been completed. When I perform the search, it's similar to what I did before. I have a Boolean variable to record that I found what I'm looking for. Just like I did before, I have a variable called stfind, into which I'll capture whatever the user types into the text box. And I've done a couple of other little things here as well. I've removed case sensitivity. You can see I've wrapped this up inside uCase, and I've wrapped this up inside uCase as well. So I'm comparing the uppercase version of stfind with the uppercase version of an item in the array. Down here, I test bfound. If it's true, if I found what I'm looking for, I do the same as I did before. I say so. If I don't find what I'm looking for, I'm now using MessageBox as a function to capture some user input. So you can see I'm feeding the MessageBox command an extra parameter, which puts the yes/no buttons onto it. Whatever the user selects will be loaded into iReply. And then I test it. If iReply equals VB yes, the user does want to add this item to the list, I redimension the array and I add the new item. Notice I'm using redim preserve because I don't want to flush the array, I want to keep what's in there already. And the value I need to put in here is the current size of the array plus 1. So you can see I'm taking ubound, the current size of the array, and I'm adding 1 to it. So the array is big enough, and I can take the data and I can load it into the upper element of that array. Job done. Now I just want to finish off by showing you how you can watch the contents of this array growing as you add new items. So the first thing I'm going to do is set a breakpoint. It's around about here where I add new items, so I'll put a breakpoint here. Now I'll start the program running, initialize my array, and try searching for something that I know is not in there. Should I add it to the list? Yes, please. Okay, I'm going to switch on one of my watch windows. I can have up to 4 watch windows. So I select watch, and in here I simply type the name of the array variable, or indeed any variable whose contents I wish to examine. Let's get the spelling right. And if I just expand this out, I can see the current contents of the array. Now as I continue to step through the program, I can see already now that once redim has executed, the array now has a length of 11. If I keep stepping, I can see now that Sue has gone into element number 10. Let's add another one. Jim. I know he's not in there. Should I add him to the list? Yes, please. Stepping through the code. I'm told he's in the list. And indeed, there he is, item number 11.
Hello YouTube, Sam here from youtube.com/onlivegamer for the new Boston. And in this tutorial, we're going to be talking about sorting arrays and reversing arrays. Now if you remember in the last tutorial, we talked about creating an array and using a normal for loop to add that array to a list box. Now in this tutorial, we're going to go ahead and start off by creating 2 new buttons. So we will add button 1 and button 2. Then we can go ahead and close out of our toolbox. We'll make these buttons a little bit bigger so they'll fit into our program, and we will set the name of button 1 to button sort array, and we will set the name of button 2 to button reverse. So now what we're going to do is we are going to come down here and set the text to sort array, and then for this one we'll type reverse array. So we'll go ahead and create events for each one of these, and under sort, what we're going to do is we're going to clear the list just in case there's anything already up there, and then what we're going to do is we are going to sort our array. So let's go ahead and we will take this right here. We will press Control X to cut it, and now what we need to do is make it accessible by all of the subs inside of this class. So we will just paste it right there, and instead of using dim, we will type private. So now this array can be accessed inside of button sort array. So now what we're going to do is we're going to type array dot, and you can see there's a whole bunch of stuff that you can use. So what we're going to do is we're going to choose sort. Now it says sorts the elements in an entire one-dimensional array system.array using the system.I comparable implementation of each element of the system array. So basically what this does is it sorts it alphabetically. So we will just sort string classes. And now we will come up here, and here is our for loop that adds every item to the list box. So we'll just copy that and paste it down here. Now if you didn't watch the last tutorial, basically what this does is we got a for loop. We have a value num as integer, and as integer is not needed because the default for for loops is integer, and it's equal to 0, and it goes to string classes.length -1. And since the length is 6 and it only goes from 0 to 5, we would get an out of bounds error if we did that. So what we do is we take -1, so it goes 0 to 5 and it still covers all 6 of those. And then we do list arrays dot items dot add string classes at the index of num. So it starts at 1 and then goes all the way to 5. So now we can do the same thing for this, but instead of sorting the array, we can reverse it. So we can type array dot reverse, and now what we're going to do is we're going to do string classes. And so if we go ahead and take this for loop again, copy it and paste it, you can see that it will print everything out. Now one thing you have to keep in mind is that when you do this, if you click this button, it's going to sort the array and it's not going to go back to the way it used to be. And when this one reverses it, it's not going to go back to the way it used to be. So if we go ahead and click add array elements, we've got all of our array elements. Now if we reverse the array, we get web design, Spanish, chemistry, English, history. And now if we click it one more time, it sets it back to normal. And now if we sort the array, it gives it to us in alphabetical order. So we've got CA, CH, we got E, H, S, and W. And now if we reverse it, we get web design, Spanish, history, English, chemistry, and calculus, which is a reverse alphabetical order. And now if we click add array elements, what this does is it resets all the values of add array elements by assigning them, and it changes it back to the way it used to be. Now this is a pretty simple tutorial teaching you how to sort and reverse arrays. Now what you can also do is just play around with this and type array dot and look at each one of these and read the description and see what you can do with that. And then once you feel satisfied with what you've learned and you know you're not going to forget what I've taught you in this, maybe you've learned something new from doing it yourself, go ahead and move on to the next tutorial, and thanks for watching.